Hello, my name is Levia Widjaya and from Business Information Technology. Today I want to explain my answer on ebook section 1.5 R25 and problem number P32. Section 1.5 R25. Which layer in the Internet Protocol stack does a router process? A router works at layer 3 on network layer. The job is to move data between different networks using IP address. Think of it like a traffic cop for the internet. It decides the best way for data to reach its destination. For example, if you send a message for someone in another country, the router figures out fastest route for the message to travel through different networks until it arrives. B. Which layer does a link layer switch process? A switch works at layer 2 or data link layer. Instead of using IP addresses like a router, it uses MAC addresses to send data inside a local network like your home Wi-Fi. Imagine you are at a party and you want to pass a note to your friend. Instead of shooting across the room, example, hey, you prefer walk straight to them and hand it over. That's exactly a switch does. It makes sure it gets data to the right device without bothering the others. C. Which layers does a host process? Across all 7 layers of the ROSI models. But the most important layer are 1. Layer 3 or network layer, they use IP address to send and receive data. Layer 4. Transport layer. They use TCP or UDP to make sure data arrives correctly. Layer 7 application layer. This is where apps like web browser, email, and messaging work. So whenever you send a text, browse the internet, or watch the video, your computer is handling data at this level. Problem P32. A. Do the delays in the interactive animation correspond to the delays in the previous problem? There are 3 types of delays that affect how fast data moves. 1. Transmission delay. The time it takes to send a piece of data into the network. Number 2. Propagation delay. The time it takes data to travel from one place to another. Number 3. Queuing delay. The time data spends waiting in line before being sent. B. How do link propagation delay affect the overall end-to-end delay for packet switching with message segmentation and for message switching? First, I want to explain packet switching, breaking message into pieces. Each packet, or pieces, is sent separately. That means as soon as the first piece is ready, it can start moving, while the rest are still being processed. This makes everything faster and more efficient. Next, I want to explain message switching, sending everything at once. The full message must arrive at one stop before moving to the next. Imagine if you had to wait until a long email was fully typed before it could be sent. It would take forever. This method slows everything down because nothing moves until the entire message is ready. For me, packet switching is way better than message switching. It allows data to move faster, reduce delay, and makes communication smoother. That's why the internet uses packet switching, so we can send message, watch video, and browse website quickly. So that's all from me. Thank you.
My name is Jasmine Naura. I will answer the question R1 1.1 and the problem number P34. Difference between a host and an end system. A host is any device with an IP address that connects to a network and can send or receive data. An end system is a specific type of host located at the edge of the network that communicates but does not forward data for other devices. All end systems are hosts, but not all hosts are end system. Type of end system: personal computer, laptop, smartphone, tablet, smart TV, streaming device, LOT device. Is web server an end system? Yes. A web server is an end system because it communicates with other device at the edge of the network without forwarding data for other. How Skype connects PC calls to regular phone? Step 1. Voice signals are captured, digitalized, and sent as VoLP packets over the internet. Step 2. Packets are routed to the Skype gateway servers, which connect to the internet to the public switch telephone network, PSTN. Step 3. VoLP packets are converted to PSTN compatible signals and routed through the telephone network. Step 4. They call reach the recipient point where the signal is converted back to analog if it's necessary for playback. The challenges: latency, jitter, packet loss, interoperability between VoLP and PSTN network. Okay, the conclusion. Skype can combine VoLP and PSTN technologies to enable cost-effective global communication, using gateway to bridge the internet and the traditional phone networks.
My name is Dian Lusiawati, and I want to answer section 1.4 R16 and 1.6 R26. The question is, consider sending a package from a source host to a destination host over a fixed route. List the delay components in the end-to-end delay. Which of these delays are constant and which are variable? The constant delay is processing delay and transmission delay. Processing delay is time taken by routers to process the package header and check for errors. It's usually constant for a particular router type, since the time required to inspect package header and perform error checking is predictable. However, it can change depending on the router's workload, although under normal condition, it can consider constant. Transmission delay is time required to push all bits of the package onto the link. This is calculated as the package length divided by the transmission rate of the link. Can be considered constant for a given packet size and bandwidth. For example, if the packet size is 1 megabyte and the bandwidth size is 1 megabyte per second, the transmission delay will always be the same under consistent condition. And the variable delay is queuing delay and propagation delay. Queuing delay is time the packet spends waiting in the queue at the router before it can transmit it. This is variable as it depends on the number of the packets arriving at the router at the same time. If many packets arrive simultaneously, the queue delay will increase. Conversely, if the traffic is low, the queue delay can be very small. Propagation delay is time it takes for the packets to travel through the medium from one router to the next. This is calculated as the distance divided by the speed of the signal in the medium. While typically consistent for a fixed distance and medium, it can vary due to change in medium, environment condition, or routing path. Second question, what is self-replicating malware? Self-replication is a type of malware behavior where a virus or other malicious program is designed to spread itself by replicating its code onto other files or systems without the user's knowledge or consent. Much of the malware out there today is self-replicating. Once it infects one host, from that host it seeks entry into other hosts over the internet. And from the newly infected host, it seeks entry into yet more hosts. In this manner, self-replication malware can spread exponentially fast.
Hello, my name is Naura Zhafarina, and today I will answer some questions. The first question is, list the available residential access technologies in your city. For each type of access, provide the advertised downstream rate, upstream rate, and monthly price. In my city, which is Bekasi, there's IndiHome with upstream rate of 100 Mbps and downstream rate up to 50 Mbps. The monthly price start from 300,000 rupiah. There's BizNet with a downstream rate of up to 300 Mbps and downstream rate is the same of 300 Mbps. The monthly price start from 350,000 rupiah. Then there's First Media with downstream rate of 300 Mbps and upstream rate of 100 Mbps. The monthly price start from 400,000 rupiah. And there is Oxygen ID with downstream rate of 100 Mbps and upstream rate of 100 Mbps. And the monthly price start from 350,000 rupiah. First is A. How long does it take for a message to arrive without segmentation? The message we will calculate is 10 to the power of 6 bits with 5 Mbps link speed. To calculate this, time equals to message divided by link speed. So 10 to the power of 6 divided by 5 times 10 to the power of 6 bits per second equals to 0.2 seconds. And since there are two switches, the message must travel through 3 links. And since each link takes 0.2 seconds, the total time is 0.6 seconds. For B, still with the same message size and still with the same formula. The difference is the size of each packet is 10,000 bits. So it will be 10,000 divided by 5 times 10 to the power of 6 bits per second, which is 0.002 seconds. This is the time to send the first packet from the source to the first switch. For the second packet will arrive at the first switch after 0.004 seconds from 2 times 0.002 seconds. For C, the time for one packet to traverse one link will be 0.002 seconds, and the total times comes to 0.002 seconds times 3 plus 0.002 seconds times 99 equals to 0.006 plus 0.198, which will bring us to 0.204 seconds. Compare this with message without segmentation, that is 0.6 seconds. And this means that message segmentation significantly reduce the transmission time. So it will save us a lot of time. D. Other reasons for using segmentations. There's bandwidth efficiency that allows for more efficient use of network resources. There's error handling that enables retransmission of only corrupted packets instead of the entire message. And there's also multiplexing, that means multiple applications can share the network simultaneously. And finally, E, disadvantages of segmentation. The first one is overhead. Each packet requires additional headers, increasing the total data size. The second is complexity. Increases the complexity of packet management and transmission. And finally, reassembly. The receiver must reassemble packets into the original message. That will be all for me. Thank you.
Hello everyone, my name is Ukalvin, and I'm here to answer the questions below. So first, the circuit switch network advantages over the packet switch network. In circuit switch network, each call has its own path, keeping the connection stable. Example, home telephone. It has reliable voice quality since the path is reserved for the entire call. Meanwhile, in packet switch network, data is sent in packets through different paths, which can change. Example, the internet. Data like emails and browsing is broken into packets, reassembled at the destination. And in circuit switch network, the bandwidth is reserved for the call, ensuring no competition for resources. Example, mobile phone calls. It ensures good call quality with reserved bandwidth. Meanwhile, in packet switch network, the bandwidth is shared among users, leading to varying service quality. Example, video streaming. Services like YouTube or Netflix may have quality affected by network traffic. Next, circuit switch network has quick communication with dedicated path. Example, teleconferencing. It has synchronized audio and video for a smooth experience with minimal delay. Meanwhile, in packet switch network, latency varies as packets are queued and routed through different paths. Example, in online gaming, lag affects gaming due to the travel time of data packets. In short, circuit switch network are great for stable, real-time communications with dedicated paths, reserved bandwidth, and quick communication. Meanwhile, packet switch networks are more flexible and efficient by sharing resources, but can vary in connection quality and latency. Next, the advantages of TDM over FDM in circuit switches network. First, efficient bandwidth usage. TDM allocates specific time slots to users, maximizing bandwidth usage. Meanwhile, FDM divides bandwidth into fixed frequency bands, leading to possible waste if not fully utilized. Second, lower interference. TDM reduces crosstalk and interference by assigning distinct time slots. Meanwhile, FDM can experience interference between adjacent frequency bands. Third, flexibility. TDM dynamically allocates time slots based on demand, better utilizing network capacity. Meanwhile, FDM requires fixed frequency bands and limiting adaptability. Fourth, simple implementation. TDM is easier to implement in digital systems, aligning well with digital signal processing. Meanwhile, FDM requires precise frequency control and filtering, making it more complex. Scalability. TDM scales efficiently by adjusting time slots for more users. Meanwhile, FDM scalability is limited by the available frequency spectrum, potentially leading to crowded bands and signal issues. In summary, TDM offers efficient bandwidth usage, lower interference, greater flexibility, simpler implementations, and better scalability, making it suitable for a real-time communication application. And next, I'm gonna answer the problem from number 33. And here's the questions. First, we need to search transmission time per package. So we use TP equals S plus 80 divided by R. And since there are 3 links, the first package needs 3 times S plus 80 divided by R. And after the first package, the remaining package follow a pipelining effect, leading to a total transfer time of D total equals F divided by S plus 2 times S plus 80 divided by R. And next, we need to find the optimal S. To minimize total delay, we use differentiations and find with S equals the root of 40 times F. In conclusion, the most efficient segment size to minimize transfer time is the square root of 50 times the file size. And by choosing it, we balance header overhead and transmission efficiency, ensuring the file reaches its destination as quickly as possible.